So we've done our ratio and proportion with mortar mixing. We even talked about it with roof slope and stuff like that. But there's a couple of things I want to show you that it can be used for. One, let's say that Colt's got a little project he's working on. And he wants to cut down a tree in his yard. Well, it's kind of a tall tree, and Colt is not sure, so he can't let it fall down this direction because it's going to fall on some power lines. Doesn't want to take down the power lines. So he has to let it fall towards his house. But he's not sure if it's going to hit his house. He wants to know if his house is safe or not. How can he tell if that tree is going to reach his house? Well, we can use what we've been talking about with these ratio and proportion and the similar figures. So let's say we have the sun here. And I'm going to do this for the sun's rays. And that tree casts a shadow. Let's say the shadow of that tree happens to be 80 feet long. Well, then Colt decides he's going to figure out how tall that tree is, he's going to use himself. How tall are you, Colt?
5'10".
So we're going to say Colt is exactly 6 feet tall. This always works well for me because I'm like 6 foot and a quarter inch tall. So I can consider myself to be exactly 6 feet tall. And he measures his shadow, and his shadow comes out to be 5 feet. So we want to know now, how tall is that tree? Well, the ratio of the shadows should be the same as the ratio of the heights. In fact, you can think of it as similar triangles. You have this, you have this triangle here and this triangle here. The 80 and the 5 are on bottom. Those are corresponding sides. And then we're looking for the height here. So we have 80 feet is the shadow of the tree compares to the 5 feet of Colt's shadow. Colt is 6 feet tall, so that goes on bottom. And we will cross, multiply, and divide. 80 times 6 divided by 5 is going to give us what? 96 feet tall? So we know the tree is 96 feet tall. Now that's not the only way we could have set this up. We could have also done the ratio of Colt's height to his shadow, or his shadow to his height, either one. We might have done 5 to 6 as his shadow to height ratio. The tree has an 80-foot shadow. But when we go to cross multiply and divide, you see that it's still going to be the 80 times the 6, and it's still going to be divided by 5. So no matter how we set this up, as long as we have those relationships in both directions, we're still going to multiply the same numbers and divide by the same number. So you just got to make sure you keep the relationships when you set these up. Well, we don't know how far it is. We haven't measured to see how far it is away from the house yet. Other applications. We've already gone over applications as far as finding the height of a roof and stuff like that, using the slope. We can use, when we go to square up a building, you set your first wall using your batter boards. You set your string across there for that first wall, and you get that first wall set. When you go to start out across here for the second wall, to make sure you're running straight, I usually measure out a 6, 8, 10 right triangle. That's using that a squared plus b squared equals c squared, 6 feet by 8 feet. Makes a right triangle with a hypotenuse that has to be 10 feet. But let's say I want to be a little more accurate. Let's say this side here is going to be 32 feet. Let's be careful. Let's do this. Let's say that side's going to be 30 feet. So I'm going to come up here to the corner of that side. How far would I go down this side? And then how far would my hypotenuse, how long would that hypotenuse have to be? Well, we have to decide, first of all, are we going to relate the 30 to the 6 or the 8? Why don't we even ask about the 10? Yeah, because the 6 and the 8 make the right corner, the right angle. So, and this is hopefully going to be a right angle here, so it needs to be one of the two sides that touch the right angle. Now, why do we get to choose whether it matches up with the 6 or the 8? Sure we do. But right now, why would we match that up with the 6 instead of the 8? Well, partly because, yeah, this side looks longer, but also because 30 divides by 6. So it's going to be an even more nice, even ratio here. So the 30 relates to the 6, as this side here relates to the 8. So you cross multiply and divide, you end up with 40 feet here. So you measure down here 40 feet to a spot, and you mark that on your form or your string or whatever. Then we're going to measure across here. We need to figure out how that is. Now we could do 30 squared plus 40 squared equals whatever squared, or we can use a 6, 8, 10 again. The 30 goes to 6 as whatever that length is goes to 10. Perfect. Cross multiply and divide, that ends up being 50 feet. So you can square up your strings for pouring your concrete and all that stuff with just some little basic math and similar triangles. They don't even have to be triangles. They can have more than 3 sides. We can have something like this. So let's say that this is 16 feet, 12 feet. We'll call this X. 6 feet, 8 feet, Y. 6 feet here, Z. Oops, that can't be 6 feet. Make that 4 feet. 12 feet. Let's just do that. Let's find sides X, Y, and Z here. First of all, do we have a side that matches up that we have both lengths for in both figures? Yeah, 16 and 12. We could reduce that to a 4:3 ratio if we wanted to, but we don't have to. To find X, where's the X going to go? It's with the 16 figure, so it goes on top. What goes below the X? I got to give you a measurement, don't I? Let me say that's 3 there. So it's going to be 3 here. So now it's going to be 16 times 3, which is 48, divided by 12 is 4 feet. So this is 4 feet. To find the Y, it's the same thing. 16 goes to 12. Y goes top or bottom? Top. And what goes on the bottom? 4. So we're going to cross multiply and divide. 16 times 4 is 64. Divided by 12 is 5 1/3. So that's 5 1/3. And the same for Z. It's still 16 to 12. Z goes on top or bottom? It's on bottom because it's from the same figure as the 12 now. And it'll compare to the 8. So now 12 times 8 is 96. Divided by 16 is 6. So Z is 6 feet. What do you think? In your book, page 512 to 513, this is exercise 23-3. 1 through 9, the odds. Also, on page 514 on the unit exercises, you can do 7 through 10.